Hello, so I just wanted to show you this so you've got an idea of where we are. We've looked at biodiversity, sampling plants and sampling animals. This lesson is about calculating biodiversity. Then we'll look at what affects biodiversity, the reasons for maintaining that, conservation in situ and ex situ, and protection of species and habitats. So that's the plans coming up. Today's lesson, though, all about calculating biodiversity. So lesson objectives then: describe how to measure species richness, species evenness. So I'll let you know what those are. We'll be using Simpson's Index of Diversity to calculate biodiversity of a habitat using this formula just here. And again, I'm going to do a step-by-step to show you how to use that formula. We'll be outlining the significance of high and low values of that Simpson's Index of Diversity. So when we look at a habitat, we need to look at the species richness. That's the number of species, total number of species you've got in a particular area. But we also need to think about the species evenness. So on Tuesday, I showed you a video of me doing a little bit of sampling in my garden, and that's pretty uneven because it's dominated by grass. So if you have one particular species dominating, then that habitat is unstable, and it means it's got a low species evenness. But the best thing to use, really, if you want to look at the biodiversity, is that Simpson's Biodiversity Index, because it takes into account both the species richness in an area and the species evenness. So species richness, then, the number of species found in a particular habitat. And the more species that you've got, the richer the habitat is. A simple count then, not quantitative enough really to give a measure of the diversity, as it does not take into account the number of individuals of each of those species. The other thing that I would add here is that sometimes you might have less species in an area, but you might have more of some quite rare species in an area. And of course, having rare species in an area is going to make that area a little bit special. So some areas are what we call special sites of scientific interest, and they get that status through having lots of a particularly rare species. So their species richness would be pretty low because they've only got a few species in there, but the importance of that habitat is high because of the fact that they've got those rare species in. So species richness, then, the number of species found in a habitat. So if we look at these two habitats here, the species richness for both of those is the same. They've both got 25 species in. So species richness is not a very good measure of diversity, because we can see, even though this has got 25, the wild meadow has got 25 species, and the grassland has got 25 species. The grassland is dominated by grass, so this has got a low biodiversity. So again, this is just to illustrate the fact that species richness is not always the best measurement of biodiversity in an area. Species evenness is a little bit better, so that does take into account the abundance of particular species in an area. And you can look out for things like here, for instance, you can see in site A that it's dominated by this cocksfoot grass, so 63%. Whereas B, you can see that the organisms are much more evenly distributed. So looking at the evenness is a much better way of trying to ascertain the biodiversity of a particular area. But the best thing to do is to try and take into account both of those things. So what we can use for that then is the Simpson's Diversity Index. So Simpson's Diversity Index then measures the diversity of a habitat, taking into account both the species richness and that species evenness. And this is the formula here. So just just to break it down for you, D then represents the diversity of a habitat. N is the number of individuals or percentage cover of a species. That's small n. Big N then the total number of all individuals or total percentage cover of all species. So I've got a step-by-step for you just here. The first thing you're going to do is to calculate that N, that total number of species. So in order to do that, then we need to add up all of the species in that particular area, in that particular habitat. Then we divide the number of individual species, so number of each individual species, by that N that we've calculated, the number of all species there. Then we square that. Then we add all those values up together. And then, and this is important because this is the step that people forget, you do 1 minus the sum of n over n squared. And then finally, we're going to write a conclusion for that. So step 1 is to calculate this value n, the big N, the total there. So in order to calculate the total, you're just going to add up the number of all of the species. So we've got 57 plus 32 plus 11, which gives 100. So big N is 100. Then we need to do little n divided by big N. So 57 divided by 100 is 0.57, 32 divided by 100, 0.32, 11 divided by 100, 0.11. And then we square that. So 0.57, I should say, multiplied by 0.57 gives you 0.3249. And a little tip here, I would do the answers for this to 4 decimal places. Sometimes you end up with pretty small numbers, so do it to 4 decimal places. And then step 4, you're going to add all of those values up. So if we add this 0.3249, 0.1024, 0.0121, and then you get this value here, 0.4394. And then we're going to do 1 minus that 0.394, which gives you 0.5606. So lastly, we need to think about what that number actually means. So writing a conclusion. So the higher the number, the more diverse a habitat is. And if you've got a low number, then that indicates you've got a less diverse habitat, so it's dominated by just a few species. If you've got a higher biodiversity, it means that if you've got a small change in that habitat, it's only going to affect one species, and therefore it's going to have very little effect on other species in that habitat. So it's fairly stable and it's able to withstand change. If you've got a low value, if you've got a low diversity, then it means if you have just a small change, that could affect one species, but that one species could potentially dominate that area, and that could have a catastrophic effect on the entire habitat. So the habitat itself is actually unstable, and it means that it's susceptible to things like disease, to predators, to man, to pollution and things like that. And it's unable to withstand that change. So over to you. I've sent you some results for the sampling that you did earlier on in the week. So I got you guys to have a look at your little quadrat. This is actually one of the quadrats, I think it's quadrat number 7, something like that. So have a look at the quadrat and identify the species. So we've got a nice little orchid in this one here. We've got a bit of the Traxacum in there, and a little bit of buttercup in there. So identify the species and then pop them in the table. So what I've done is I've combined the results of a couple of sets. So if it doesn't look familiar, that'll be why, because I've combined results. And then I've calculated a frequency. So out of all of the data that I've got, I've worked out a frequency. I've shown you how I've done this in the worksheet. And what I'd like for you to do is to have a look at both the species richness and calculate the Simpson's diversity index for both the sites. So we were looking at two different sites. Site A then is a species rich hay meadow managed organically and traditionally. So this has only been managed in that way for 15 years. So 15 years ago, both these sites looked exactly the same, and with that new management strategy, they have actually started to see a difference in the diversity of these two different sites. Site B then is agriculturally improved cattle grazed meadow. So it's got very, very high nutrients in that particular area, and that affects the biodiversity of that area. All of these pictures on this screen are from this one Lass National Nature Reserve, so I would quite like to go and visit it, and maybe we can visit it as a trip, who knows. So I'd like for you to use the data collected that's in the worksheet then to calculate the species richness and the Simpson's diversity, and I want you to write a conclusion for that as well. Okay, good. If you have any problems, you can contact me via Teams in our normal lesson times, or drop me an email, and I'm happy to help you with your calculations if you get a little bit stuck. Bye.